All right, today we're jumping into a really clever new way to speed up AI. And it's all about a simple, powerful idea, training our models to work smarter, not just harder. The technique is called AdaSPEC. Let's get into it. You've definitely been there, right? You ask a super powerful AI a question, and then you just watch that cursor blink and blink and blink. It turns out the very thing that makes these models so amazing, their complexity, is also what makes them so slow. But what if there was a way to speed them up without losing any of that power? Well, the key to that speed up is a technique called speculative decoding. It's this really promising idea for making these huge models generate answers way faster. And the cool part is, you don't even have to change the giant model itself. You just change how it works. Okay, so here's a really simple way to picture it. Imagine you have a brilliant world-class expert. Their answers are always perfect, but man, they take their sweet time coming up with them. That's our big target model. Now, to help out, you hire a super fast, eager assistant. That's our small draft model. The assistant's only job is to quickly jot down a few words or tokens in AI terms of what they think the expert is going to say next. Then, the expert just has to glance at the draft and say, yep, that's right, which is way faster than coming up with it all from scratch. Right, so if this whole system hinges on having a great assistant, the big question becomes, how do you actually train a good one? How do you get that little fast model to be an amazing guesser of what the big, slow model is thinking? Well, the standard way to do this is a classic technique called knowledge distillation, or KD for short. And the idea here is that you don't just train the small model on a bunch of random data. No, you have the big, smart teacher model train the little student model directly. Let's switch up the analogy for a sec, because this one's perfect. Think of a wise old mentor, our teacher model, training a young, eager apprentice, our student model. The mentor isn't just handing the apprentice a pile of textbooks. They're actually showing them how they think, their intuition, all their little shortcuts. The apprentice learns to mimic the mentor, basically absorbing all that distilled wisdom. So how do we know if the apprentice is actually learning anything? Well, for that, we use a mathematical tool called KL divergence. Now, don't let the name scare you. You can just think of it as a similarity score. It just measures the gap between what the mentor predicts and what the apprentice predicts. The entire goal of training is to shrink that gap and get that score as close to zero as you possibly can. So this all sounds perfect, right? The mentor trains the apprentice to be just like them. It seems like a foolproof plan. Well, it turns out there's a hidden flaw in this whole setup. We're actually training for the wrong goal. The problem really comes down to a simple fact. The apprentice model is just way, way smaller. It doesn't have the same brain power as the mentor. So what happens when that brilliant mentor tries to teach the apprentice some super complex, nuanced idea that's just completely over its head? Exactly. The apprentice just struggles. It wastes its limited mental energy trying to understand these hard lessons. And in our speculative decoding world, that means the fast assistant starts making a bunch of bad guesses. The expert has to keep rejecting them, and the entire process just grinds to a halt. The whole team becomes inefficient. And this slide right here just nails the core problem. The goal of standard knowledge distillation is to make the apprentice a perfect clone, to mimic the mentor on absolutely everything. But the real goal we need for speculative decoding is way more practical. We just want to maximize the number of correct guesses. We don't need perfection, we just need a really high success rate on the stuff it can learn. The training goal was completely misaligned with the real-world job. This misalignment is where the researchers had their big aha moment. They thought, wait a minute, what if we just change the lesson plan? And that brings us to AdaSPEC and its incredibly clever smart filter. The core idea behind AdaSPEC is actually really simple, but so powerful. Instead of trying to force the apprentice to learn every single thing the mentor knows, it takes a step back. It first figures out which lessons are easy enough for the apprentice to actually learn and which ones are just too hard. And it does this in two very smart steps. First, it trains a temporary model called a reference model that basically acts as a filter. This model's whole job is to go through all the possible lessons and flag the words, the tokens, that are just consistently too difficult for a small model to get right. Then, in step 2, the real draft model, our assistant, gets trained. But here's the kicker. It's trained only on the easy tokens that made it past the filter. Okay, now take a look at this because it shows you exactly how this filter works. You see that sentence at the top? AdaSPEC looks at it and decides that in this context, words like then or has are just too unpredictable for the small model, so it filters them out. And as you can see on the bottom, it focuses all of its training effort, that AdaSPEC loss, only on the tokens it knows are learnable, the ones with the green checks. It's not training harder, it's training smarter. So this whole smart filter idea sounds amazing on paper, right? But the real question is, does it actually work in practice? Well, the researchers put AdaSPEC through its paces on a whole bunch of different tests to find out. And the paper pretty much sums it up perfectly. They found that across all the different tasks and model setups they tried, AdaSPEC consistently got a higher token acceptance rate. And that's exactly what we want. It means our fast assistant is making more correct guesses, and that speeds up the whole operation. This table really breaks it down for us. On the left, you've got the old method, the baseline. And on the right, you have AdaSPEC. Just look at those acceptance rates. For math problems, it's a boost of over 3%. For coding, over 1%. Summarization, another boost. Now, these might look like small numbers, but in the world of inference speed, they add up to very real, very noticeable improvements. This chart kind of tells the whole story in one picture. On the left is the performance of the old method, and on the right is AdaSPEC. You can just see that the whole distribution is shifted to the right. The takeaway is crystal clear. AdaSPEC's performance is just systematically better, giving its higher acceptance rates across the board. And this case study is really, really cool. So the blue text shows mistakes that both methods made, but the red text, that shows mistakes that are unique to that method. And notice on the right for AdaSPEC, there's almost no red. Its mistakes are almost all mistakes the old method was already making. It has learned how to stop making new, unforced errors. So what does all this mean for you and me, the people actually using these things? Well, it means real, tangible speed-ups. In some of their tests, the researchers saw up to a 20% faster generation speed compared to the very best method that came before it. That's a huge improvement that really cuts down on that annoying waiting time. So the crucial point, the big takeaway, is this. By just letting go of that impossible goal of perfect mimicry and instead focusing the model's limited brain power on what it can actually learn, AdaSPEC creates a way more effective and efficient assistant. It is a true masterclass in training smarter, not harder. And all of this leaves us with a really provocative thought. Maybe the future of AI isn't just this endless race to build bigger, more expensive models. Maybe, just maybe, it's about finding these clever, more efficient ways to train and use the models we already have. And that makes you wonder, what other parts of AI are we training inefficiently, just waiting for another aha moment like this one?